This presentation is about pointers as used in C programming language. By definition, a pointer is a variable that holds memory address of another variable where actual data is stored. Before we get into the pointer topic, let us discuss on certain basic concepts in C programming language. In C programming language, we have variables, and whenever a variable is declared, a memory location will be named with that variable name. Every memory location will be having some unique address. So binding of a variable to a memory address is done by the compiler automatically. Now let us consider one example. If I declare a variable BPC with the statement int BPC, the compiler will find a suitable memory location and that will be given the name BPC as you see in the diagram in the right side. We can also see that the address of the memory location is 2002. Considering one more example, character DC. So there again, one memory location will be randomly taken by the compiler and given the variable name DC. The memory address of that location is 2005. Now let's see what happens when values are assigned to a variable. Say BPC equal to 57. So the computer will get the location whose name is BPC and load the value 57 in that particular memory location. So DC equal to M also mean the same thing. The value M will be stored into the memory location with address 2005, which also has the name DC. With this understanding, let us see what is pointers and how a value can be accessed with the help of pointers. A pointer is a variable that can be used to store the address of a memory cell. So a memory address can be stored in a pointer variable, and the purpose of doing so is that this can be used as a reference to that same variable name whose address is stored in the pointer. Let us consider two more variables, PVB and PVD, as shown in the right side diagram. If you are storing the addresses 2002 and 2005 in those variables, PVB will act as a pointer to the variable BPC because the address of variable BPC is now contained within the variable PVB. And similarly, PVD can be used as a pointer to the variable DC because the address 2005 of DC is now loaded in PVD. So pointers allow us for indirect addressing. Through the pointer variable PVB and PVD, we can access the values 57 and M. Now let us see how a pointer variable has to be declared and initialized. A pointer variable can be declared with help of the syntax type of the variable star pointer variable. Now here type defines to the variable type to which the pointer variable is actually pointing to. Now let us consider a few examples. Int star p. Now p is a variable that can hold the address of another integer variable. When I say float star q, q becomes a pointer variable that can store the memory address of another float variable. Now we have two important operators here, star, which is otherwise known as indirection operator or asterisk symbol, ampersand symbol, that is the address of operator. And the peculiarity of address of operator is that if we use address of operator before any variable name, we will be able to access the memory address. Now let us go back to our example. We have in BPC equal to 57. So one memory location 2002 is loaded with value 57. And if we proceed with the pointer variable declaration in star PVB, we are going to get a pointer variable by the name PVB. Let the address of PVB be 2012. Now when I say PVB equal to ampersand BPC, what happens is that the address of variable BPC will be collected and loaded into the location PVB. So 2002, which is the address of BPC, is now taken and put inside PVB. So we have PVB now acting as a pointer or reference to the variable BPC. Now here is a simple example. Now we have two variables BPC and XYZ. BPC contains 57 data and XYZ is having the data 25. We have two pointers star P1 and star P2. Both of them are initialized. First one is initialized with the address of BPC. Second one initialized with the address of XYZ variable. And now what happens is that if we try to print out the data by direct mechanism and indirect mechanism, it can be done as following in the four printf statements. Now printf data1 equal to percentage d comma BPC. So we are directly getting the data 57. In the second printf statement, printf data1 through pointer equal to percentage d comma star P1. There, since P1 contains the address of BPC, we will be redirected or the reference goes back to the variable BPC, thereby retrieving the value 57. And the last two printf statement, printf data2 equal to percentage d comma XYZ. So directly we are printing the answer 25. Last statement, printf data2 through pointer equal to percentage d comma star P2. Now star P2 here again is a reference to variable XYZ. So when we say star P2, we will be getting the value contained in the variable XYZ. So here again the data 25 will be printed in the screen. So here is the illustration. So P1 gets 2002 and P2 pointer gets the address 2005. So thereby both of them act as pointers to BPC and XYZ respectively. So here is the output. So 57 by direct mechanism, 57 again through a pointer, second data by direct mechanism, and finally second data printed or accessed through the pointer mechanism. Now let us consider one more example. Now we have the first four statement, same from the previous example. BPC equal to 57, XYZ equal to 25. Then P1 and P2 are declared as pointers. We have P1 initialized with the address of BPC, P2 initialized with the address of XYZ. Then we change the value in BPC with the help of the statement star P1 equal to 100. So when we say star P1, we are pointing to the location BPC. We are referring the location BPC, thereby value 100 will be loaded into BPC. So 51 will be erased, 57 will be erased, and 100 will be loaded into that location. In the following statement, star P2 equal to star P1 plus 15. So star P1, it means we will be getting the value 100. 100 plus 15. So 115 will be loaded into star P2. So P2 is pointing to the location XYZ. So 115 gets loaded into the location XYZ through indirection. Okay, now in the following four printf statement, let us print the answers directly and indirectly. In the first statement, percentage d comma BPC, so we directly access the latest value from the BPC. Then star P1, so we indirectly access the value from BPC with the help of star P1 notation. Third printf statement, accessing the second value directly. Last statement, percent d comma star p2, accessing the second value indirectly with the help of p2. So this will be the results we'll be getting. BPC gets the value 100 and XYZ gets the value 115. Now here is another program that is for swapping two numbers. So PTRX and PTRJ, they are two pointers which will be initialized to point to XY variable and JK variable. Now XY and JK gets two values. Now we make use of a temporary variable for performing the exchange operation. So the first value from XY variable will be loaded into TMP with the help of the indirection operator star PTRX. Then after that, star PTRX equal to star PTRJ. That means with the help of pointer operator, we are loading the second value into the first variable. Then star PTRJ equal to temp. So we have the value buffered in temp register that will be loaded into the second location with the help of star PJ. So the last three printf statements for printing the latest answer. So finally, going on to the benefits of pointer.